Bye.
And then three of them.
Turn off the logo.
Go back and look at what
You'll let me know. So how many days did you miss? Just yesterday. Oh, and Friday too. Oh yeah, because Friday was a test, yeah. Okay, did you guys check your graphs on the graphic calculator? Yes or no? Height or EA? Okay, D, then what is the problem? Okay, D, Y equal to, okay, now we're going to have a quiz on Thursday. You must know all 6 graphs. Okay, so if I were you on Tuesday, the first thing I would do is draw the base graph, because then maybe you might get a point for that. So cosine inverse, doesn't it look like that? Yeah. And then what does this do to the graph? Reflect it over the y-axis, so then this point comes here, and then da-da-da-da. So now it looks like this. I should have drawn a dotted line, yeah? Oh, then I should have drawn this dotted line. And then what does that do to the graph? It multiplies the y-coordinates by 2, so you just go boom. Come on. And then the hardest part for you guys is you guys got to remember how to draw the base graphs. So what are you guys going to do? Resort to memorization. Now what is that? Is that an L? Or is that 1? H-I-G. What? I don't know. Is that the carrot somebody always draws? Okay, do we know how to graph that? Do we know how to graph that? Do we know how to add? Oh boy. Okay, so here we go. Cosine inverse looks like this. Right? Sine inverse looks like this. More contracted there. Okay, and then just add the 2 together. So like what's, okay, so for every x value, you add the y coordinates. What's negative pi over 2 plus pi? Pi over 2. What's 0 plus pi over 2? What's 0 plus pi over 2? In fact, every time you add, like what if you add right here? What is this plus negative that? You can get pi over 2. So every time you add them, you get pi over 2. That's why you end up with just a straight line segment like that. In fact, if you graphed it on your calculator, it wasn't just a little line segment like this. And then h and I are the same thing except different. Arc tan x plus arc cotangent x. So pi, and then, okay, we don't even need it. Okay, so arc tangent x looks like this, right? Cotan inverse x looks like this. What happens when you add them together? Every time you add them, same thing. 0 plus pi over 2 is pi over 2. You double this, you get pi over 2. So no matter where you add, it comes out pi over 2. So what happens is you just get this line going all the way across like that. And then I, same thing. Y equal secant inverse x plus cosecant inverse x. Okay, so cosine inverse looks like this. So secant inverse, remember, it's gonna hump right and hump left. Sine inverse looks like this. So the horizontal asymptote will be here, and then you hump right, and then you hump left. And again, what happens when you keep adding? Negative pi over 2 plus pi is pi over 2. Every time you add, it comes out pi over 2. So that's why you get this and that. How come there's no graph in between there? That's because there's no graphs in between there. How can you add two graphs when they're not even there? So what's the lesson to be learned in these three problems? Cosine inverse x plus sine inverse x always comes out to pi over 2. Of course, if you're in the domain, right? Between -1 and 1 here. Arctan x plus cotangent x, that's always pi over 2 also. And same thing here. This is always equal to pi over 2 in the domain of the problem, which is from -1 to the left and from 1 to the right. And today you're going to see why that is when we go over these things. Okay, I don't think I'm going to give you G, H, and I on the Thursday's quiz, but you are going to have the other ones. You're going to have to take a base graph and do stuff to it. And garage ball bearings, you're going to have C there. Did everybody finally get C? Sunrise. Shift and then reflect. Shift it one to the left and then reflect it over the Y. Garage ball bearings, that's one of them. Okay, so tonight's homework is number 3, but then you got A through Z. Okay, so the first thing you've got to be able to do is evaluate inverse trigonometric values. So let's start off easy. Sine inverse 1/2. What does that mean? Now remember, sine inverse is the inverse of the sine function. So here's you. Okay, when you see this, this is what you got to be thinking. Okay, here's you. You got to be thinking, sine of what angle is 1/2, but the angle has to be in the range. What's the range for sine inverse? -pi/2 to pi/2. Which means there can only be one answer, because every year students give me more than one answer. There is only one answer because this is a function. For every x value, there can only be one y value. Okay, so if you're giving me more than one answer, then you're not understanding this. Okay? There's a range. There's only one answer that lies in the range. So sine of what angle is 1/2, but that angle has to be between -pi/2 and pi/2. What? Sine of what angle is 1/2? Pi/6. How come not 5pi/6? Because it's not in the range. If your answer is not in the range, then that's not the answer. And if your calculator has the range built in already, so no matter what you do, it's going to spit out an angle between -pi/2 and pi/2. Okay, let's do another one. Cosine inverse 1/√2. So you should be thinking in your head, cosine of what angle is 1/√2, but the answer has to be in the range, which is 0 to. Have we memorized the ranges yet? Because I'm telling you, that's the key to this whole chapter. So what is it? Cosine of what angle is 1/√2? Pi/4. How come not 7pi/4? Because 7pi/4 isn't in the range. There's only one answer in the range. Okay, let's do another one. Tan inverse √3. Okay, I'm not going to write anything down. Tangent of what angle is radical 3? And the answer has to be in the range, which is from -pi/2 to pi/2. Pi/3! Oh, so Mr. Park, if the argument is a positive number, then the answer is just a first quadrant angle. Yes! So you can probably guess on the quiz and test, you know, why would I give you a positive argument? Anybody can do that, right? So now let's do some negative ones. Sine inverse -√3/2. Sine of what angle is -√3/2, and the answer got to be in the range. is sine negative root 3 over 2? Okay, on the unit circle, it's what? There and there, right? So what is it? Is it 4 pi over 3?
No.
No, how come? Because the answer is not in the range. Okay, what about 5 pi over 3? No, that's not in the range either. So what's the answer? Negative pi over 3. That's the only one that's in the range. Yeah, but Mr. Park, isn't negative pi over 3 the same place as 5 pi over 3? Yeah, it is. On the unit circle, it is the same place. But numerically, is this number between negative pi over 2 and pi over 2? No. Negative pi over 3 is the only one that is, so that's why that's the answer. Okay, let's do another one. Cosine inverse negative 1 over root 2. Cosine of what angle is negative 1 over root 2? So you should be thinking here, right? Kataka, kataka. But the answer got to be in the range. The range for cosine is 0 to pi. So that must mean this one right there, which is 3 pi over 4. Are we getting the hang of this? Tan inverse negative 1. Tangent of what angle is negative 1? That would be here, right? But there's only one that lies in the range, which is negative pi over 4. How come it can't be 3 pi over 4? Because it's not in the range. How come it can't be 7 pi over 4? It's not in the range. You guys understand this? You guys did this last year, right? So if the answer is not in the range, that's not the answer. Don't write it down. And if anybody writes more than one, I'm going to take off triple on the quiz. I know Kojima's going to do it. Okay? And then of course got the other ones, like what about this? Secant inverse, let's just do a little more practice, negative 2. Secant of what angle is negative 2? I guess you should be thinking cosine of what angle is negative half then, right? And the answer got to be in the range of secant inversions, which is from 0 to pi, so 2 pi over 3. Cotan inverse negative root 3. So cotangent of what angle is equal to negative root 3, which of course means tangent of what angle is negative 1 over root 3. I don't know how you guys think. And the answer got to be in the range. The range for cotan inverse is from 0 to pi. 5 pi over 6. Okay, so when you have these, as long as you know the range, you can do the problem. Okay, now let's look at some other. Now I know you guys did these last year, so you can't tell me you did. Okay, what about stuff like this? How do you compute the, oh, before we even do that, so after all of this, what is an inverse trig function? It's an angle measurement. It's an angle measurement, that's what it is. And we do radius, but you could all put your calculator in degree mode, it'll spit out a degree measurement. It's an angle measurement. Now, before we go any further, like what if I give you a 3, 4, 5 triangle? What if I ask you, what is the measurement of that angle right there? What would you tell me? There's 6 ways of labeling this angle. Is that, okay, first of all, is this a number we know? Oh, of course, in physics, you guys know that, right? In physics, 36.9 degrees. Come on, people, when you guys show off 3, 4, 5 triangle in physics, doesn't the teacher say that's 36.9 and that's 53.1? Who's your teacher? Okay, whatever. 36.9 degrees, but that's not exact. That's just an approximation. What is the exact measurement of this angle? Well, tan inverse 3/4. That's because the tangent of this angle is 3 over 4. Or you could say cosine inverse 4/5. Because the cosine of this angle is 4/5. Sokator. You just gotta know sokator. Or sine inverse 3/5, because the sine of this angle is opposite over hypotenuse, 3/5. Or you could say, no, boost breath, it's cotan inverse 4/3, or you can say it's secant inverse 5/4, or you can say it's cosecant inverse 5/3. All 6 of these mean the same thing. It means that angle right there. Okay, now let me, after seeing this, now on your calculator you're supposed to check last night's homework, right? So if you have secant inverse x, how do you graph this on your calculator? If you don't have a secant inverse button, some of you are searching for it. Secant inverse button. Check on the calculator. What? So how do you punch this in on your calculator? Cosine inverse 1/x. Now can you see why secant inverse x is the same as cosine inverse 1/x? Look, right here. Cosine inverse 4/5 is the same as secant inverse 5/4. What's the relationship between that and that? They're reciprocals of each other. That's why secant inverse x is the same as cosine inverse 1/x. So if you want to do this right now, so you guys can see it for yourself. Okay? If you want to see secant inverse on your calculator, you punch in cosine inverse 1/x. And then why don't we do a zoom decimal? Zoom 4. There you go. Up left, then up right. See? Oh, so Mr. Park, how do you graph cosecant inverse on your calculator then? What do you do? Sine inverse 1/x. Okay, try that. Okay, that's it. Up right, up left. Okay? So you think you're good, yeah? How do you graph cotan inverse? Oh, then Mr. Park, by the same reasoning, I can just go tan inverse 1/x. Okay, try that. Graph tan inverse 1/x. That doesn't look like cotan inverse. Cotan inverse looks like this, right? If you remember. Is that what you're seeing in your calculator? No, Mr. Park, how come it worked for that one and that one, but this one doesn't work? Because of the range. I'm telling you, the restricted range is the key to this whole chapter. If you don't get those restricted ranges down, you're done for. Just write the name on the top of the paper and hand it in. That's because these two have the same range. These two have the same range. That's why it works. But these two do not have the same range because this range is from 0 to pi. This one is from -pi/2 to pi/2. That's why you don't get the same graph. So no, EA, 9 yet. So how do you graph cotan inverse on your calculator? Okay, Chai is saying pi/2 minus tan inverse x. Okay, try.
What does invalid mean?
It's calling you a name. No, that means, usually it only comes up, you know when you're doing statistics, that means you have more x values than y values or something. Wait, what?
I have no clue.
Yeah, but you already drew a graph, right?
Yeah.
Okay, another reason you can be an invalid dimension is your stat plots are on. Anytime you have a graphing problem, are your stat plots on? Should I go to stat plots?
Yeah.
Well, how did it turn on all of a sudden? There's only 2 reasons. Either you're in AP stats or you're playing games.
I think I saw points on the graph and then I tried to delete them. So
Okay, so try punch this in. Did this work? Ooh, I wonder why that one worked. Somebody tell me why this works. It's in the notes! Look at the notes on the bottom right. Oh my goodness. Okay, so does everybody understand what an inverse trig function is? It's an angle measurement. It's an angle measurement. Now, usually in mathematics, when you're given an angle, you can name any 6 of these to name that angle right there. But what's the best one to use? this one. Because you can actually see what the angle looks like. Tan inverse 3/4. All you have to do is make sure opposite over adjacent is 3/4, and that's going to be the angle. So you can kind of see what that angle is. Okay, so like here, tan inverse 1/2. Can you visualize what that angle is? 1. So what you do is you make this 1 and then 1, 2, right? You make the ratio 1 to 2. That angle is tan inverse 1/2, opposite over adjacent. Because that's like slope, right? Rise over run. So tan inverse is the best one to use because you can actually see what that angle kind of looks like. In fact, if you have to approximate this, okay, this one, well, this one's not really drawn to scale. 3, and a little bit more. 3/4 would kind of look like this. So what would that be? About, I just told you. 36.9 degrees. 37 degrees about. Okay, what about this one? Somebody give me something good here. If you have to guess, what's an educated guess? Zane. Come on, guess what that angle looks, what does it look like? 60, 70, 80? Well, no, we're not leaving the room till you come up with a guess.
60.
Okay, time out. Time out. Okay, if this is 1 and 1, isn't that 45-degree angle right here? So if you make the side longer, doesn't it have to be smaller than 45 degrees? So 60, 70, 80, those are not good guesses. So what would you guess now then? 20. That's kind of close. I would guess like 27. Am I right? Check on your calculator. Tan inverse 1/2. Yeah, but the calculator's giving me radians, Mr. Park. Then multiply it by 180 over pi, or put it in degree mode. So what is it? See, close to 27. You just have a feel in your bones. Okay, so after you get a feel of it, then you can play the tan inverse game. This is what we do at Christmas in our house. Somebody shouts out tan inverse something, and then whoever can guess the closest degree measure wins the prize. So somebody come up with a number. Crazy, whatever. Just a crazy number. 8 over 15. But see, that's close to 1/2. Except, okay, is it going to be bigger than 1/2 or smaller than 1/2? Well, 1/2 is 8 over 16, right? So this is a little bit bigger than 1/2. It didn't take you really that long. So if we know 1/2, what did we say? It was 26.5 degrees. So something a little bit bigger, what would your guess be? 27 or 28 degrees, yeah? So what is it? Do I have to get my calculator? You guys have all your calculators out. 28 degrees, see? You would have won the grab bag if you got that. Okay, then here, go like that. Tan inverse, I don't know, root 10. Okay, so it helps to know if you know radical 10 is 3.162 approximately. But we already know tan inverse 3 is 72 degrees. So it'll be a little bit bigger, but how much bigger? Just a little bit. So I don't know, 72 point some, 73 at the most. How is this taking so long? 72.45. Thank you. Thank you very much. But that's because we play at our house. We play the tan inverse game. You guys just laughing. Hey, nobody's gonna do that. If you play this game, then you're gonna understand the inverse trig functions. Okay, so the beginning problems that you have are like that. Okay, but now let's kick it up a notch. How would you compute the cosine of tan inverse 5/12? Like, is 5/12 a number we're supposed to know for tangent? Like, the tangent of one angle is 5/12. Like, if this was like 1 radical 3 or 1 over radical 3, then we could figure out the angle exactly. But I don't know this angle. Well, you don't know it, but can you draw it? Yeah, you did this last year, right? I'm almost 100% sure, which is 99 point something. So call this angle theta. I don't know what it is, but the tangent of it is 512. So just do SOHCAHTOA. 512, opposite over adjacent, and then 512, 13. So what is, even though I don't know exactly what this angle is, can I compute the cosine of this angle? Yeah, what is the cosine of this angle I just drew? Adjacent over hypotenuse, 12 13ths. SOHCAHTOA. Now is this coming back like a bad dream from last year? You draw, so if it's not an angle, a number that you know, you draw the triangle. Okay, let's do one more. What is the cosecant of cotan inverse 17/8? No! 15/8. Okay, so let's call this angle theta. How do you draw an angle so that the cotangent of it is 15/8? Don't you do this? And then fill in the third side with the Pythagorean theorem. 17. So what's the cosecant of this angle that I just drew? 17 over 8. Right? Hypotenuse over opposite. All you gotta know is SOHCAHTOA. Okay, let's do it. You guys think you're good now, right? What is the cosine of tan inverse 4/3 plus secant inverse 13/5? So these are both numbers I don't know, so draw the triangle. Let's call this one alpha. So tan is opposite over adjacent. And let's call this angle beta. What is secant? Hypotenuse over adjacent. So it's 5/13. Okay, so how do I find the cosine of this angle plus this angle? Just distribute the cosine. Just find the cosine of this and add it to the cosine of that. No, you gotta use identities. This is the cosine of, if we call this alpha and beta, is it alpha plus beta? Do we have an identity for that? Yes, it's cosine alpha, cosine beta, minus sine alpha, sine beta. You don't just distribute the cosine. That would be a triple fatal error. And then once you apply the identity, then you just look at your triangles. What is cosine alpha? 3/5. What is cosine beta? 5/13. What is sine alpha? 4/5. What is sine beta? See, all you gotta know is SOHCAHTOA. And then you make a least common denominator, so you get 15 minus 48, which is negative 33 over 65. Oh, so Mr. Park, we gotta know all our identities there. Yes! Height. Okay, let's do a couple more and then we're done. What is the cosine of 2 times arc cotangent? Give me any number. 12. Oh my, okay. Want to go with 12? We go with 12. Now, is this an angle that I know? Arc cotangent 12? No. But I can draw it. It's going to look like this, huh? If the cotangent of this angle is 12, doesn't it mean this is 12 and 1? Yeah, and so using the Pythagorean theorem, isn't this root 145? You picked the number. You picked it. Okay, so what's the identity for sine of 2 theta? Do I just look at sine theta and then double it? Don't you ever do that. This is sine 2 theta. 2 sine theta cosine theta. So now you look at your triangle. Sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And then you get 24 over 145. Can I reduce that? Or is that the answer? You can reduce it, right? The 4's cancel out. 2 over 15. Okay, last one. We'll just do one more. Tangent of 1/2 sine inverse 0.28. Yeah, like that one. Okay. Is 0.28 a number I'm supposed to know for sine? No. We only know like 1/2, root 2 over 2, and root 3 over 2, 0, and 1. That's not it. But can I draw that angle though? Yeah, 0.28 is like 28 over 100. Wait a minute, which is 7 over 25. See, if you change it to 7/25, easy. So sine is opposite over hypotenuse. You guys remember doing this right last year, right? So you guys can. So there you go. That's your triangle. You draw for it. So what is tangent of half of this angle? I gotta use half angle identity then. But there's 3, Mr. Park. Well, what's the best one to use? I keep telling you. 1 minus cosine theta over sine theta. So once you apply the identity, just look at the triangle. 1 minus cosine theta is adjacent over hypotenuse. SOHCAHTOA, come on! Sine theta, I don't like using SOHCAHTOA, but I think we have to this year. Sine theta is opposite over hypotenuse, and then multiply top and bottom by 25. So you get 25 minus 24 over 7, which is 1/7. Pretty nice answer. Yeah, so the second half of tonight's homework is all using identities. Okay, now, this is all review from last year. Now, tomorrow, then we're going to learn new stuff with inverse trig functions, like how to solve equations with them. Did you guys do that last year? Oh, you guys did? How come Chai is saying yes? Because he went to Kaiser? You telling me Kaiser is better than Iolani? Chai? Oh, you took summer school. Trig. And you solved equations like this. Did you solve equations like this? Sine inverse x equal cos to, I don't know, like 2 cosine inverse x. Put a 2x here like that. Oh, you did. And then you guys are polar too then, right? Oh, so you could have an advantage when we study polar. Because you guys didn't learn polar, right? They skipped it. But that's okay, I'll teach you like you don't know anything. As usual. Okay, we're done. How much time is left? 8 minutes left. So the quiz is going to be Thursday now. You gotta know those 6 graphs. Well, I guess you don't have to. You can bum it. And then on the test, which is going to be, I guess, next week sometime, I'm not going to ask you to graph. I'm going to ask you questions about the graph. Which means you got to know what the graph looks like.